Let's discuss moisture in screeds. This overview of slabs and screeds is based on general facts and figures. There are many variations as to the types, times, and thicknesses that are affected by the type of construction, application of building, weather conditions, and other mitigating circumstances. We have taken an average of these. The structure of your screed should be something like this: a black plastic DPM, unless it's a very old building, which creates a moisture barrier beneath the slab. Thus, moisture can only evaporate through the slab on the surface of the slab. Followed by a substrate. This is made up of concrete. This can vary in size and construction depending on the required strength and application of the building. And a topping, which is made up of cement and a fine aggregate mixture. The moisture content in the screed comes from the water used in mixing the cement and concrete, and it should evaporate slowly through the top surface during the drying and curing of the subfloor. Water is added to the product for two reasons. Firstly, to create flowability so that the product can be poured into place. Secondly, the water and the concrete have a chemical reaction called hydration, and this is what cures the concrete to the correct hardness. To properly cure the concrete, you need the right evaporation rate. Many years ago, you would see builders watering a slab or screed in order to dry or strengthen it. This was to ensure that it stayed at the right temperature and moisture levels to ensure well-cured, strong slab with no cracking. And after a period of time, approximately 28 days per 25 millimeters, the slab would be sufficiently dry for the flooring to be fitted, and we did not encounter too many moisture problems. So what has changed? In recent years, we more regularly come across screed moisture problems. And why is this happening? There have been changes in the design and construction of concrete. The use of fly ash to replace between 15 to 30% of concrete, as well as additional chemical additives which increase strength, can also possibly slow down the drying process. In the last 15 years, the water to cement ratio has increased from 0.5 to 0.6 or 0.65. 66% of the water added to concrete is to create the flowability, and the rest is required for the hydration process. The excessive use of power floating and pan floating creates a hard crust on the surface, making an impermeable layer for below surface moisture to evaporate. Fast-track building does not allow time for screeds to sufficiently dry out. It is for these reasons that when it comes time to fit flooring in a project, there is a much greater risk that the subfloor is not sufficiently dry and could cause a failed installation. It is therefore absolutely essential to do a moisture test prior to beginning installation of either your floor covering or application of self-leveling compounds. We at Polyfloor advocate a moisture test that probes 40% into the screed. A surface reading only is not sufficient. While there are surface instruments that claim to measure within the depth of the slab, the Polyfloor International opinion is that this could give a false result depending on the construction of the concrete. We would suggest using a Wagner-meter or a protometer. Any reading over 75% relative humidity would be unsuitable to begin installation. The following case study will clearly indicate that the residual moisture deep in the slab has a significant impact on the success of the flooring installation. This experiment done in Australia was that 7 days after pouring the slab, the moisture readings were almost identical top and bottom of the slab. 92% RH at the top, 97% RH at the bottom of the slab. Within 68 days after pouring the slab, much of the surface moisture had evaporated, and the surface reading had dramatically decreased to around 57% RH. However, a reading taken 40% into the slab still presented moisture levels of around 83% RH. The flooring was then fitted on day 68, creating an impenetrable surface barrier, and immediately redistribution of moisture began. 10 days after the flooring was fitted, the moisture near the top of the slab had risen to 78% RH, and at 40% it was 83% RH. 72 days after the flooring was fitted, the moisture in the slab had balanced, and the RH at the top and the bottom of the slab had both reached around 82%. From that example, you can clearly see the need for a moisture test that probes 40% into the slab and measures RH percentage within the slab depth. A surface test will indicate a floor ready for vinyl installation, but 2 to 3 months later, you could be faced with moisture problems affecting your installation. So what happens when flooring is laid on a surface where moisture levels are in excess of 75% RH? If you have laid a self-leveling screed over a too wet substrate, firstly, there is a good chance it will delaminate or come loose from the base. It will also not reach its correct hardness or MPa level and could show or be subject to indentations of heavy traffic. When the moisture rises and mixes with the adhesive, which is usually an acrylic adhesive, the adhesive will emulsify and lose its grip. Emulsification can be speeded up in areas with heavy traffic, as the traffic assists the mixing of the moisture and the adhesive. The most critical time for moisture not to mix with your adhesive is during the adhesive curing period, which is somewhere between 10 and 20 days depending on the type of adhesive. Once the adhesive has emulsified, your flooring comes loose as it no longer held down by the glue bond. With sheeting, bubbling will occur. With tiles, they could peak or come completely loose. With all of this in mind, how do we manage the risk of an installation failure as a result of moisture? First and foremost, no self-leveling or flooring product should be laid until a moisture test measuring 40% into the slab has been done and a reading of 75% RH is achieved. This means waiting for the screed to dry out sufficiently before beginning the installation. Readings with dates, meter used and moisture content should be recorded. Preferably do not power float or burnish the screeds, as this significantly delays the moisture evaporation. If the screed has been power floated, grinding it to open up the surface will assist in speeding up the drying process. The ultimate solution is always to specify a suitable moisture barrier. There are several good moisture barriers on the market, some for slightly lower moisture levels and some designed for very high moisture levels. They are all either cementitious or epoxy type products that are applied over the top of the screed and always below the self-leveling compound. So what are the advantages of using a moisture barrier? It is time saving. As previously discussed, we live in an age of fast-track building. Time is money. Building programs do not allow sufficient time for screeds to dry. Specifying a moisture barrier is going to ensure your program is not delayed by a wet screed and your installation is safe from failure. It will also offer long-term protection should your black plastic DPM become compromised. If the building is in an area with unusually high water tables or is built on clay, it may continue to have unusually high moisture levels after the initial drying period. Ultimately, it allows peace of mind that the moisture will not be a problem at the time of installation or any time after that.